Okay, so moving on from where we just were, which was worked out y1 squared minus y2 squared, we're ready to integrate now using this nifty little formula here. In fact, I'll try and circle it for you so you know exactly what we're going to be using as we go on. You can probably guess what it would be like if we were to rotate it about the y-axis instead of the x, but we'll come to that as we move on. Let's now do the actual integration itself. If we just scroll down a bit. And we end up with pi the integral of 8x to the power of 4 minus 62x cubed plus 119x squared with respect to x between the limits 0 and 7 over 2. Perform this integration, we end up with pi 8x to the 5 over 5 minus 62 x to the 4 over 4, obviously you can simplify that down if you want to, plus 119 x cubed all over 3 between our two limits 7 over 2 and 0. Substitute that into your calculator and evaluate it. Obviously the 0 term creates nothing here, so it's just a 7 over 2 you really need to be worried about, and you should end up with 103,243 pi all over 480, which luckily I can do in my head. This is units cubed, obviously, because we've just worked out a volume, and that's volume of revolution between two curves. Alright, the next video is going to be you having a go at a similar example, so obviously go back over this and make sure you understand what I've just done fully, and we'll pause and move on hopefully to make sure that you can do this before we do some differential equations.